Alright guys, open up in your brand new books to page 381. So even though it's a new book, it's still like the pages start where the other book left off. So it's on page 381, which is at the very beginning of your new book. The reason why we are doing this as a video is twofold. Number one, I don't know how long my voice is going to last. It's been rough the last few days, so instead of me having to say this 4 times in a day, I just have to say it once. And also there's been a lot of people out, so this way those who are absent are not missing the lessons. When they are absent, they can still get the lessons. So on page 381, we're moving into geometry, which might be more exciting for some of you. Shapes and angles and triangles and area and volume and all that kind of stuff is what we're going to be looking at over the next several chapters. So we're moving past the algebra stuff. There will still be algebra in geometry. So algebra and geometry are really strongly connected. So you will see some algebra creep in, but the topics will be more geometry focused. So some people, I think, like it a little bit better. It's more on the artsy side of the brain. But there are some things you need to know, and we will start with some terminology with lines, angles, and this one's probably a new one for you guys, transversals. First of all, pairs of angles can be classified by the relationship to each other. And one special case occurs when 2 lines intersect to form a right angle. So if 2 lines intersect and form a right angle, we say that these lines are perpendicular to each other. And the symbol we use for perpendicular is basically kind of like an upside down T. But we would say that line L is perpendicular to line M. So that's how we would read that. But instead of saying all that and writing all that, math, we like shorthand. We don't like to write too much. So this means the same as this. We use this little symbol here to indicate perpendicular lines. So if we want to show that something is perpendicular and we don't necessarily know how to draw it perfectly straight, or in your book if you see this, that always means that the lines are perpendicular. Now 2 lines in a plane that never intersect, you guys already know this from our work with systems, but those are parallel lines. A line that intersects 2 or more other lines in a plane is called a transversal. So any line that intersects 2 or more lines is a transversal. So R would be what we call a transversal. And the symbol we use for parallel is just 2 parallel lines right next to each other. So we would say that S is parallel to T. Now, if the transversal is perpendicular to one of the parallel lines, then what do you think is true about if A is perpendicular to C, then A is also going to end up being perpendicular to B. So there's a few things there. The other thing we're going to be looking at, and this is on page 382. Hold on one second. Okay. So now when we have transversals and parallel lines, and that's what this section is mostly about, when parallel lines are cut by a transversal, then there's 8 angles that we're going to be looking at here, and they're numbered here, 1, 2, 3, 4, 5, 6, 7, 8. 4 of the angles are interior angles, so these 4 right here are interior because they're between the lines, and then the 4 that are outside those lines are exterior angles. So let me see if I can find, okay, so the interior angle's there. And we can just call it angle 3, angle 4. So this is how we identify each angle. Use the symbol, not just the number. So this way we know it's an angle that we're talking about. And then the exterior angles are angle 1, angle 2, angle 7, angle 8. So in this section, you need to know the symbols that we use as well as the new terminology. Interior, exterior, transversal, all these different things you should be familiar with. And there actually are some boxes on page 382 for you to fill in with the interior angles and these exterior angles. Now, let's see here. When 2 parallel lines are cut by a transversal, there is a relationship between these. So these angles actually come in certain pairs. Those are alternate interior angles, alternate exterior angles, and corresponding angles. So alternate interior angles are angles that are on the interior and are on the opposite side of the line. So 3 and 5 would be alternate interior. 4 and 6 would be alternate interior. Alternate, opposite sides, interior, they're both on the inside. So again, this is on 383. There's some boxes you can fill in here with this information. Alternate exterior, 1 and 7 because they're on the outside, they're on the exterior, and they're on the opposite side of that transversal. So alternate means they're on the opposite side of that line, and then exterior, they're outside the parallel lines, not inside. So then 2 and 8 are also alternate exterior. Then the other one is corresponding angles. Corresponding angles are in the same position on the same side of the line in relation to the transversal. So like 2 and 6, they're on the same side of the line in kind of the same spot on each of the parallel lines. And 1 and 5 are corresponding angles. 3 and 7 would be another example. They're on the same side of the line in kind of the same position relative to their line that they are on. Excuse me. And then 4 and 8, so you can fill in those boxes there. So there's a lot of things to think about when you have these angles and parallel lines. But we're going to start just by classifying, and then we're going to look at the measurements of each of these. So look at page 384. We're first just going to classify these angles, and then we're also going to use the relationships to kind of find angle measures. So classify the relationship between 1 and 7 as either alternate interior, alternate exterior, or corresponding. So 1 and 7, first of all, are they interior or exterior angles? We know they're exterior, so we can get rid of this. Are they on the same side or opposite side of the transversal? And if you look, one's on the left, one's on the right. So they're opposite sides, so they're alternate and they're exterior, which means they would be alternate exterior angles. What would be another pair of alternate exterior angles on here? Think about that. Okay, so let's look at another example on page 385. 2 and 6 on page 385. What would 2 and 6 be? First of all, they're on the same side of the transversal, so they can't be alternate. If they're on the same side, they can't be alternate, and the only other choice then we have is corresponding. So are they corresponding? Are they in the same position on their respective lines? Yes, they are. So what would be another pair of corresponding angles in this figure? You could have 4 and 8, 3 and 7, 1 and 5. Those would all be corresponding angles. Okay, let's look at, now that we kind of are able to identify alternate interior, alternate exterior, corresponding, there are some relationships that we can use with those. So just watch this really quick, and then we'll talk about some examples.
Parallel lines. Parallel lines cut by a transversal have special angle relationships. Let's number the angles.
Their handwriting
Now,
is so neat.
measure each angle and record the measurement in the table.
A lot of the same numbers.
Next, mark the angles that are congruent to angle 1.
Fill these in on page 386.
To indicate congruent angles. Mark the angles that are congruent to angle 2. Use 2 arcs to show that these angles are congruent. Notice that the angles with 1 arc and the angles with 2 arcs are supplementary. For example, angle 1 and angle 2 are supplementary. Now notice the position of the congruent angles. For example, vertical angles, such as angle 1 and angle 4, are congruent. Alternate interior angles, such as angle 3 and angle 6, are congruent. Alternate exterior angles, such as angle 1 and angle 8, are congruent. And corresponding angles, such as angle 3 and angle 7, are congruent.
Okay, so a few things. I think that you guys should already know what supplementary angles are. So what are supplementary angles? Angles that add up to 180 degrees. So 1 and 2 are supplementary because they add up to 180. 105 plus 75 is 180. 1 and 3 are also supplementary. 105 plus 75 is 180. So supplementary angles add up to 180. Vertical angles are directly across from each other. So vertical angles are always congruent. Two angles that are right next to each other that form a straight line are supplementary, add up to 180. But notice that there's only two. Out of these 8 angles, there's only 2 different measures. So you need to know those relationships. You need to know that vertical angles are congruent. You need to know that alternate exterior angles are congruent. 1 and 8, 2 and 7. Alternate interior, 3 and 6, 4 and 5. Corresponding, 2 and 6, 4 and 8, 1 and 5, 3 and 7. You need to know which pairs are congruent to each other. And if you know one of these angles, we can find the measure of all 8 of them because of these relationships. Now again, we use this symbol to show that they're congruent. So all the ones with 1 arc, those are congruent to each other, then the 2 arcs are congruent to each other. So those are a few things that you need to understand there. So if I know one angle is 50 degrees, then I know a bunch of these other angles. What's the measure of angle 2 going to equal? Well, 1 and 2 have what kind of relationship? Those ones are supplementary, so this has to be 130 degrees. And then angle 3 is a vertical angle with angle 1, so if 1 is 50, then 3 has to be also 50 degrees. And 2 and 3 are also supplementary, so these also have to add up to 180. And then 4 is vertical with 2, so that one's 130, or supplementary with angle 3. So there's a lot of different ways we can look at these relationships here. But there's our other angle there. So we're going to practice some of this on page 387. And this video will be posted online, so if you missed any of the blanks, you can go back and look at it. It's in Plus Portals now, actually. Not now as I'm recording it, but now as you're listening to it, it will be in Plus Portals on today's lesson plan. So here's an example. Mrs. Kumar designed the bookcase shelf. Line A is parallel to line B. In a bookcase, you typically want your shelves to be parallel, right? And then she also kind of made a fun design where it's not just like straight shelves here. But here, if you think about this, this is parallel lines cut by a transversal. 2 lines are the shelves, and then this other division is the transversal. So I can kind of look at these 8 angles, and if I know that angle 2 is 105 degrees, I can find any of these other ones. So 2 is 105, and I want to know what 3 and 6 are. Well, 6 should be easy because it's right next to 2. So if 2 and 6 form a straight line, then what is angle 6 going to be? Well, if they're supplementary, then their angles add up to 180 degrees. And if those angles add up to 180 degrees, then whether this did not keep going here. Okay, there we go. So 180 minus 2, which is 105 degrees, is 75 degrees. So angle 6 is 75 degrees. Now, angle 3. Is this related to 2 or 6 in any way? What's the relationship between angle 6 and angle 3? They're actually a special pair that we talked about. Since they're on opposite sides, they are alternate, and since they're between the parallel lines, they are interior. And we said that alternate interior angles are what? Yes, congruent. So, I think I missed something. This is not loading for some reason. Oh, there it is. Okay. Angle 6 and angle, they're exterior, interior, that lay on the opposite side of the transversal. So, their measures are equal, and that means if 6 is 75 degrees and they're equal, then 3 is also 75 degrees. Good. You guys are so smart. Alright, go to page 388, our last example, 388. This is a long one today. Okay, in the figure, line M is parallel to N, and Q is perpendicular to P, and the measure of angle 1 is 40 degrees. We've got a lot of stuff going on here, so let's see if we can figure this out. what's the measure of angle 7? Okay, so we know that these two lines are parallel, and they're actually cut by two different transversals, Q and P, and these two transversals happen to be perpendicular to each other. So P is a transversal and Q is a transversal. So we're going to kind of work our way around and find that angle that we're missing, which is angle 7. Now it's not supplementary to 8, but it's supplementary to 8 and 3. So maybe if we find 3, we can use that to find 7 and vice versa. We'll see what we can figure out here. So first of all, 1 and 6, because 1 and 6 are alternate exterior angles, their measures are equal, right? Now the measure of angle 1 is 40 degrees. Did it say that? Did they give us that information? Oh yeah, they did tell us that the measure of angle 1 is 40 degrees. Okay, good. So if the measure of angle 1 is 40 degrees, then the measure of angle 6 is also 40 degrees. And on your papers, like, it might be helpful. What I always used to do was like write this. So this is 40, so you can kind of see it. But then if that's 40, then it might be helpful to just draw in 9 is also going to be 40, and we said that 6 is also 40. And what other one is also 40? Can you guys see it? Angle 3. Why is angle 3 also 40? Because they are opposite, vertical angles. So 3 is also 40 degrees. So now if you look here, 7, 8, and 3 all add up to what? Those would all add up to 180 degrees, right? So if 7, 8, and 3 form a straight line, or we can use 6, 7, and 8, I guess 6, 7, and 8 all form a straight line, so those would also equal 180. Then we can very quickly find angle 7 in just a second. So 6, 7, and 8 all add up to 180. And we know that 6 is 40 and 8 is 90. So that means that 7, and you can do all these steps if you want, or if you can use just mental math, then that means that there's only 50 degrees left for angle 7. So angle 7 has to be 50 degrees. And again, just use those relationships. Like I said, if you want to just once you know one of them, kind of figure out and mark off which ones are congruent to each other, figure out which ones are supplementary, so on and so forth, and use those supplementary and angle relationships to find the angles that you are missing. Okay, that's where I'll stop for now.